Great.
Hi, everybody. Michael Silber here, Event Director for Enlit Australia. Once again, talking to an industry leader about issues currently impacting the industry. Today, we're very fortunate to have with us Mike Davis, who's the Innovation Manager with Jemena. Welcome, Mike.
Thanks, Mike. Great to be here.
Yeah, good to meet you. Hey, today we're going to talk about biofuels, particularly as it relates to distribution networks. So I'd like to begin just by asking, can you give us a bit of an overview of what the bio industry segment is in particular as it relates to the to distribution networks?
Yeah, so I guess what we're really focusing on is bioenergy from waste. So particularly from municipal organic waste, sewage, agribusiness, and effectively how we can extract the energy from that organic waste in the form of a gas that can be utilised in a gas distribution network.
So I understand one of your goals is to connect your customer with lower emission options. Could you elaborate on that, and particularly as it pertains to biomethane?
Sure. So we've got a number of customers that are requesting optionality in terms of their gas use and ways in which they can decarbonise. So a couple of gases that we're looking at in terms of renewable gases, renewable hydrogen, and also biomethane. Effectively, we're just trying to find ways in which we can enable that gas to come into our network, so our customers can have access to that for their demand profiles.
You've mentioned to me in the past that biomethane is a net zero solution. Can you explain that in a little bit more detail?
Yeah, so it's about the carbon life cycle of organic material. So typically in our life cycle, organic material is going to absorb carbon dioxide, and as we consume and that material is broken down, it's then going to release gases. So it's going to release methane and CO2 as part of a natural organic life cycle. Where it's different from fossil fuels is, of course, that fossil fuel is organic material that was trapped from previous millennia. And when you actually utilize that gas, you're actually releasing carbon dioxide that was absorbed in that organic life cycle from millennia ago.
So waste to power as it was conceived 15 years ago is no longer a viable generation solution. And to use your words, it's out of the money. What does that mean?
Well, not in all circumstances. So I think waste to power, as in waste to generating electricity, makes sense when you have a large demand at the source of where that waste gas is, or you've got ways in which you can really get some of the efficiency benefits. So you've got an electricity load, but you've also got a demand for some of the heat that's generated when you're generating that energy. Where it tends to be out of the money going forward is in relation to power gen for exporting electricity to the grid. Because there's a couple of challenges with that market. One is the gas itself, if it's not cleaned up in its entirety and it's run through generators, it will contain things called siloxanes and other contaminants, which can create a lot of maintenance issues for the engines. And of course, because it's often a variable source of energy, that the power that's produced is also intermittent and variable. And even if it's consistent, it's not responsive. So when the gas is available, it generates and produces electrons, but not on demand. So they don't really meet what's going to be required in this energy market is more sort of flexible generation to meet our changing demand profile and to meet that gap between intermittent renewable generation. So I think that's where we're looking at. It may make more sense to keep the value of that energy in a molecule rather than converting it to electron. As a molecule, you have natural energy storage through your existing gas infrastructure. So if we can get that molecule into gas infrastructure, then we can use that molecule on demand and decarbonise or have a net zero solution for some very difficult to decarbonise energy demand, like heat and responsive generation.
So on that on-demand solution, it could be used both for behind the meter and for back on the grid, on the distribution grid. Can you elaborate on that a little bit?
Yeah, so if we can clean that gas up and we can get into the gas grid, so if I look at, say, New South Wales gas grid, which is what Jemena own and operate in New South Wales, that's about 25,000 kilometres of buried pipe. So what it enables is a storage solution. So there's equivalent of about 8 million Powerwalls, Tesla Powerwalls in terms of the energy stored in that network, just because of the diameter of the pipes, the pressure in which it's in there, and the molecules that are in there. And so if we can get that gas in, then obviously customers then have the flexibility of how they use that gas. So customers with, say, heat demand, which is generally not coincidental with wind and solar, it's an alternative option for them to decarbonise their heat load. And of course, if you've got distributed generation, or even better, you've got behind the meter generation like cogen and trigen, which is much more efficient, then you can use that renewable energy molecule on demand to provide a really high efficient, responsive generation to through that generation.
So how does all of this fit into what is now called the circular economy? Can you talk a little bit about that, biomethane and the circular economy?
Yeah, well, I mean, I think if we're going to talk about circular economies, I think the first thing to do is to sort of stop treating waste, or even calling waste waste. So I like to think of if we're going to achieve decarbonisation, we have to see ourselves as part of an ecosystem, a life cycle. So you see how sort of ecosystems evolve, and nothing's wasted. Anything that goes on the forest floor, is utilized and becomes nutrients and regenerates plant growth and things like that. So all we're doing is looking at ways in which we can create that circular economy, so we stop wasting waste. So in terms of biomethane, we can do waste a whole lot better. So rather than organic material being shoved in a giant hole, which is our Australia's way of often managing waste, and then extracting some of that gas and either flaring it or generating electricity, we can actually have a better way. We can actually get that organic into an anaerobic digester, and thereby starving it of oxygen and introducing bacteria to rapidly break that organic material down. By doing that, then you can actually create value streams from that product. We can actually produce the gas, which I'm talking about, but much, much better and more efficient volumes of that gas, which we can clean up and get into the gas grid. But we also have other value streams that come off that, like the nutrients that are in that organic material, which is not generally termed digestate, but that can go to farmers or agribusiness. And again, that saves farmers having to use often some fossil fuel-based digestates like ammonia and things like that. And finally, there's the CO2 stream. Now, I know our aim is to reduce the CO2 out of the environment. So there's opportunities to utilise that CO2 stream that comes out of that process as well. So effectively, we can just look at this waste stream. We've got an energy value. We've got potential CO2 for industrial use, or perhaps we can utilise that for greenhouses, and then you've got the digestate. So by linking up all these economies, we can actually find a value proposition which does a couple of things. It keeps it means that the produced stream shares its value. So gas customers get gas that recognises the other commercial benefits of that circular economy. So gas users aren't paying a premium for that gas. They're actually playing part of that the full net benefits of that circular economy.
That's great. You used a phrase in there which I think becomes a headline, which is "Stop wasting our waste." I really think that's terrific. Mike, I want to thank you for your time. Really appreciate it. Really valuable stuff. And I'm going to invite you to speak at some point at our live event, which is planned for early next year in Enlit, Australia. But once again, thanks for your time, and look forward to catching up in the near future.
I appreciate the opportunity. Thanks, Michael.